Hi, welcome to my video on the reciprocal of a rational expression. Reciprocal of a number. Recall, one number is the reciprocal of another if their product is 1. If we take the number 2 over 3, the reciprocal is 3 over 2. So 2 over 3 times 3 over 2. Notice we're multiplying, and we can cancel the 3's out, cancel the 2's out, and we'll get a 1. The reciprocal of a negative 4 over 7 is a negative 7 over 4. Now you could write 7 over negative 4, but the negative doesn't stay in the denominator. Excuse me. Negative 4 over 7 times negative 7 over 4. The negative times the negative is a positive, so there it cancels out. So 4's cancel, 1's, 7's cancel, and you get 1. Now you could multiply 4 by 7 to get 28, and get 28 over 28 to get 1, but I like to cancel when I'm multiplying fractions. 6 is understood to be 6 over 1. The reciprocal is 1 over 6. So 6 times 1 over 6, and the 6 is over 1. You're multiplying, so you cancel top to bottom, and you get 1 over 1, which is 1. Note the numerators and the denominators are integers in this case. So, let's look at the reciprocal of a rational expression, which follows the same pattern as the integers. Rational expression, x over 3, reciprocal, 3 over x. So x over 3 times 3 over x, the x cancels, the 3's cancel, 1 over 1, which is 1. Again, notice you're multiplying. So when you're multiplying, you cancel numerator to denominator. 7x is 7x over 1, so the reciprocal is 1 over 7x. So 7x times 1 over 7x. Remember, you put that over 1, you see that they cancel to give us 1. Reciprocal is x minus 6 over x plus 4. Reciprocal, just turn it upside down. And when you multiply them, let's see. We're multiplying, so we get x minus 6 over x plus 4. Because we're multiplying, we cancel top to bottom anywhere. Cancel top to bottom. The x plus 4's cancel, the x minus 6 cancels. I get 1 over 1, which is 1. Reciprocal is x squared over 2x minus 3. 2x minus 3 over x squared times x squared over 2x minus 3. We're multiplying. We can cancel. 2x minus 3 cancels top and bottom. X squared cancels top and bottom. We get 1 over 1, which is 1. And again, a reciprocal is just turn it upside down, turn it over. So notice the reciprocal. The 4x minus 4 and x minus 1 goes to the numerator. 2x times x plus 2 goes to the denominator. And then this takes a while to write all this down. But as you can see, there's the first one. And there's the second one. It's reciprocal. And because we're multiplying rational expressions, we cancel. 2x cancels. The x plus 2's cancel. The x minus 4's cancel. The x minus 1's cancel because they're all on top and bottom. They're all 1's. So you get a 1. And this is 4x minus 7 understood to be over 1. So the reciprocal, notice putting it over 1, it goes 1 over 4x minus 7. Again, it's like 7x is over 1. Reciprocal is 1 over 7x. So think about it as being over 1. So you see the reciprocal. So 4x minus 7 times 1 over 4x minus 7. This is over 1. 4x minus 7's cancel, and we get a 1. So the reciprocal of a rational expression, just turn it upside down. Change your denominator, put your denominator in the numerator place, and put your numerator in the denominator's place. Practice. Get the reciprocal of all of these. Find the reciprocal. And I'm going to put down find the reciprocal, and let's see, here we go. Find the reciprocal, x over 9. And don't forget to pause the video and work these out if you wish. And gets x plus 6 over x. Notice the x's cannot cancel. You can only cancel x plus 6 if you have an x plus 6 as a factor on the bottom. 10 over x minus 1. Reciprocal, 2x minus 3 over 2x. Reciprocal, x minus 11 over x plus 6. Reciprocal, 4x is understood to be over 1, so reciprocal is 1 over 4x. Reciprocal is x minus 2 over x squared plus 4x. Reciprocal, x squared minus 4 all over x squared minus x minus 2. Reciprocal is x squared plus 6x plus 5 and over x squared minus 2x minus 3. X minus 10 is understood to be over 1. The reciprocal is 1 over x minus 10. And the reciprocal of 1 over 7x plus 4 is 7x plus 4 over 1. But we don't bother to write down the 1, so it's just 7x plus 4, understood to be over 1. Number 12, the reciprocal. The denominator becomes the numerator, and the numerator becomes your denominator. Okay, so reciprocal. Now, we did something like this before, but it's just another review. Just doesn't hurt to review. Negative numbers of rational expressions. Recall, 1 over x is the same as 1 over x to the 1, which is 1 over x. X to the negative 2 is 1 over x squared. X to the negative 1, it could be the same as 1 over x to the 1, which is 1 over x. So notice now I have this here twice. This one, I did it as 1 over x to the power of 1. Right here, I did it as the reciprocal of x to the 1 power, which is just 1 over x. And this is 1 over x squared, which is 1 times 1 is 1, x times x is x squared. So again, this one is, I did it as 1 over x to the power of 2. Whereas right here, I did it as the reciprocal of x, which is 1 over x to a positive power. Again, very similar. And what about 1 over x to the negative 1? Well, the best way to do this when you have a fraction again is just get the reciprocal. So it's x to the power of 1. And get the reciprocal, it's just, again, x to the power of 2, so it's x squared. Reciprocal is x over 3 to the 1 power, which is x over 3. So when I have a fraction inside and I have a negative exponent, I flip the fraction as a reciprocal and leave it as a positive power. And that would be true here. So as you can see, I have x minus 3 to the 2 power, x minus 3 over 2 to the power of 1, which is x minus 3 squared. X minus 3 divided by 2. Sorry about that. And the negative 1 power gives me x over x plus 1 to the 1 power, because the negative exponent gets the reciprocal of the inside to the 1 power, so it's not going to change. And to the 1 power, again, I got a negative exponent, so I get x plus 7 over x plus 6 to the 1 power, which is x plus 7 over x plus 6. So again, to a negative power, do the reciprocal of this fraction. It makes it easier. And what I should do is show you right here, show you this one right here. Let me show you this one another way. Watch this. 2 over x minus 3. If I can write it down. 2 over x minus 3 to the, that's an x minus 3. So if you do it the other way, and you go, it's 1 over 2x minus 3 to the 1 power. So that becomes 1 over 2 to the 2 over x minus 3. And because we're dividing here, then you multiply by the reciprocal. So it's rather than, if you say this is to the 1 power and go 1 over this to the 1 power, and you got to multiply by the reciprocal because you're dividing, it's quicker to do 2 over x to the negative 3 as x to the negative 3 over 2. It's quicker to flip this as a reciprocal like this than it is to go through all this. But this is the background behind it. Again, 4 over x to the negative 1 is the same as x over 4 to the 1 power. And 3x minus 1 over x plus 4 to the negative 1 power is x plus 4 over 3x minus 1. And this is a cube, so a negative exponent makes it x over 2 cubed. And x over 2 cubed is x over 2, x over 2, x over 2. And that gives you x cubed over 8. So notice the negative gets the reciprocal of 2 over x to x over 2, and then you work at your power. Number 4, negative 1, reciprocal, x minus 3 over x plus 7 to the 1 power. And number 5, what's the reciprocal of x minus 1 over x minus 4? Well, the reciprocal is x minus 4 over x minus 1. Because the reciprocal, you flip it upside down. And notice number 6, it's x minus 1, x over x minus 4 to the negative 1. Because it's to the negative 1 power, we get the reciprocal. Is number 5, which is this one, and number 6, is number 5 and number 6 equal? So that answer right there is the same as that answer, and the answer is yes. In other words, what am I trying to say? The reciprocal alpha, the reciprocal of a rational expression is the same as a rational expression raised to an exponent or a power of negative 1. So what we're trying to say is that the reciprocal, saying the word reciprocal on this, is the same as saying the same expression raised to the negative 1. And that's the review of the reciprocal of a rational expression, because you need the idea of reciprocal when you're dividing, because we know, or should know, when we divide, we have to when we divide fractions or any numbers, we have to multiply by the reciprocal. That will be in the next video. If you like my video, click the like button, the subscribe button, the notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content is on my YouTube channel called Math Fully Explained. Thank you for viewing my video.